So let's take a look at section 3.1. So we are going to talk about central tendencies. We're going to talk about we're going to talk about the mean, the median, and the mode. You may remember this from probably middle school. We're going to start with the super basics. It should be kind of a review. If you don't remember, no big deal, because we're going to go from the basics. And then we will take this and put it on steroids as we move through this course. So let's get going then. So measures of central tendency, basically that's different ways of just saying averages. So it describes the average or the typical data value. So we've heard average miles per gallon, average commute time to work. We've heard average household income, the height of the average woman. I don't really think it's 5'4" I think it's taller than that, but this is what they say it is. So this is different ways we've heard average. So the arithmetic mean, or the mean, is computed by we add all of the values together and then divide by the number of observations. So, for example, if I had 6 people and I wanted to average their weights, I would add all 6 weights together and then divide by 6. So the population arithmetic mean, so the population, remember population means everybody. So if I were to finding the average commute time for all RCC students, if I talked to every single RCC student and then divided it by the number of RCC students, I would get the population arithmetic mean. We use this little symbol right here. This is called mu. Looks like a weird little U with an extra tail, and it is called mu. And it's using all the individuals in the population. So remember, the population mean is a parameter, because remember, a parameter is based on the entire population. The sample arithmetic mean, so if we took a sample data, so we're trying to figure out the average commute time of all RCC students, and we took a sample of 50 students and then averaged those together. That would be the sample. And we would use this, so that would be a sample. It would use this symbol right here. We call that X bar, and that's just for the sample. They're computed the same way. However, one is by averaging everybody's and the other is by averaging your sample. So remember, sample mean is a statistic. Remember, statistics are descriptive numbers based on a sample. So statistics are samples, parameters population. Let's move on. So right here is how we determine our mean. Yes, this looks very daunting, but all it's telling me is add all of them together, divide by the number we have. If we get a decimal, it is standard to round the mean to one more decimal place than the raw data. So for example, if my raw data was all whole numbers, then we would round to the tenths place. If my raw data had to the tenths place, we would round to the hundredths. So let's actually do some math here. We're going to compute the population mean of this data. So I'm going to add together 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43. Then I will divide by the number that I have. So I have 1, 2, 3, 4, 5, 6, 7. I have 7 different data points here. So I will divide by 7. So I'm just going to put that in my calculator. Plus 36 plus 23 plus 18 plus 5 plus 26 plus 43. That gives me 174. Divide that by 7. And I get 24.9. So it's approximately 24.9 minutes would be the average commute time for those 7 employees of the web development company. I'm assuming, it says all 7 employees, so they must only have 7 employees. So this would be a population mean. Oops, let me erase that now. So I'm going to take a simple random sample of 3 employees. I'm just going to take 3 of them. I'm going to use my calculator. So if you have a TI-83 or TI-84 calculator, if you click your math button, and then arrow over to number, or to num, and go down to, let me see here which, okay, I lied to you. Sorry about that. I don't want to re-record the whole thing, so I'm just going to erase this. So you go to math, then you arrow over to PR, I can't write correctly apparently. Arrow over to PRB and down to 5. 5 is rand int. So that's random integer. And I want to choose just 3 of these. So when I click on rand integer, I'm going to do 1, 3. So I will do rand 1, 3. Sorry, 1, 7, and it's telling me to choose a random integer between 1 and 7. And that will give me my first random. So it gave me a 6, so the 6th one is 26, so I'm going to use 26. And then I'm going to hit the enter button again, and that gives me the 4th one. 1, 2, 3, 4. The 4th one is 18. And then I'm going to hit that again, and it gives me the 3rd one. The 3rd one is 23. So I'm going to get a sample mean based on these 3 numbers. So 26 plus 18 plus 23 divided by 3 is 22. So the sample mean of those 3 is 22.3. If I do it again, I'm going to need more room. I'm going to do it over on the left side here, and I'm going to do that in blue. So I'm going to do that again. I'm going to do my random integer again. 1 to 7. And I get 36 plus 5 plus 43. And I'm going to divide that by 3, and I get 28.0. So as you can see, you're going to get a much more accurate answer by using the population, but sometimes that's not possible. Clearly, using only 3 of them is not going to give me a very good answer, because look, I've got 28 and 22.3. Those are so far off of each other. But that was how you get the sample mean. The sample mean is just take a random sample of the whole population, and it needs to be random. So take a random sample of the entire population and use that to get your sample mean. So here's some practice for you. So I would like you to pause this video and find the population mean, and then using your random integer button. So remember, that is math, then arrow over to PRB and click on the number 5, which is rand int, and you're going to want to have rand int, and there's 10 here, 1 comma 10. And if it gives you, for example, if you got a 4, you would go down to the 4th one, and the 4th one would be Pam, and you'd hit enter again, and if that gave you 8, your 8th one would be Sam. So do that. Choose 4. First, find the population mean, add them all together, divide by 10, find that population mean. Then with a random sample of 4, find a sample mean, then do a second one. And go ahead and pause this video and do that practice. So I'm going to add those all up now. Hopefully you already did that. I'm going to add these all up. And when I divide by 10, I got that the population mean was 79. Hopefully you got that. If you didn't, go back and try it again. So random sample size of 4, it could be any 4. So one of my random samples of 4, I got 80. My other random sample of 4, I got 72. Clearly those are very far apart. I got 80 here and 72 here. The 80 is pretty close to my population mean, but the other one is pretty far away. Once again, if you can use the population, use the population. Remember, if you have any questions, make sure to send me an email or send me a message through My Open Math. Please make sure you are telling me that it is not from the homework, that it's from the video. I apologize if I misunderstood anybody who sent me emails previously. Remember, we're all new to this. Okay, so the median is another way of finding average, and we use this a lot when we have outliers, and I'll explain what outliers are later. But the median is the middle when we arrange the data in ascending order, so you need to make sure to rearrange the data. So here is how we find the median. Arrange the data in ascending order, so put them in order from smallest to biggest. Then figure out how many observations you have. We'll call that n. Determine the observation that is in the middle of your data set. So let's take a look at the travel times again. So I'm going to put these in ascending order. So 5, 18, 23, 23, 26, 36, and 43. So these are now in ascending order from smallest to biggest. I have 7 data points. So mine that is in the middle is the 4th one. So that 4th one is in the middle. So this middle point right here is my median. So 23 would be the median. So suppose that we had a new employee and that employee has a 70-minute travel time. So now we need the median of this new data set. So I'm going to once again arrange them in ascending order. 26, 36, 43. But now I have 8. So I have 4 here and 4 here. So there is no middle. Oops, sorry about that. There is no middle. So what I need to do is I need to take these 2 numbers, these 2 that are in the middle, and I'm having issues getting my pen to work, and I need to average them. So I would do 23 plus 26 divided by 2, and this is going to give me my median. So my median now is, oh, I'm having issues with my pencil. Sorry about that. My median now is 24.5. That is not significantly different than, significantly different, for some reason I'm having trouble speaking, sorry about that, than the median that we had before. Now, if we were going to be using mean on this, the mean would change significantly. So I'm just going to show you real quick what would happen to my mean. So my mean with just the 7, so my mean here with just the original 7 was 24.9. I'm going to add that other point in there, that's 70-minute commute in there, and I'm going to show you how different it is with, so without 70, this is without, and I can't write, without 70, so with the 70, my mean is 30.5. That is significantly different. And this is why we would use our median, because sometimes you get a value that is far outside what the norm is, and it skews that. It changes your mean significantly. This is why when we're doing like house prices, home prices, We generally use the median because if you have like a foreclosure where a house is selling for super low, or you have like one multi-million-dollar house, that can skew your mean. That can cause your mean to change significantly. Or if you're using like incomes, if you have a CEO that makes multi-million-dollars, but everybody else's income in the company is a lot lower, it's going to make it look like the average income is a lot higher. And sometimes they do this on purpose. Like they do it, for example, with teachers' incomes a lot. They do it on purpose in order to make it look like people make more money than they do. So let me continue here. So here's a practice. This is the length of songs. So I would like you to pause the video and see if you can find the median length of songs. Make sure to put them in order from smallest to largest and then find that median. So go ahead and pause, and when you come back, I will go through it with you. Okay, hopefully you did that on your own. I'm going to put these in order now. So I have 179. I like to cross them off while I do them. 201, 206. I already can see that I'm writing these too big, but it is okay. I'll make it work. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9 songs. So we'll have 4 below, and 4 above. So my median length of songs would be 217. I'm hoping you got that. If not, and you're confused, go ahead and send me an email and I will try to address that. Okay, let's find the median test score then. Do the exact same thing. Put these in order. Go ahead and pause the video, or if you feel like you have it, obviously you can just move on. Pause the video and see if you can find that median test score. Okay, so I've got 62, 68, 71. Okay. As usual, I ran out of room. Okay, so as with when we added that extra data with the commute to work, we have an even number. So I have 5 here and I have 5 here. So I need to take these two and I need to average them. So I do 77 plus 82, divide it by 2, and that is 79.5 would be my median test score. So what was the mean test score? Just a second, let me go back. So my mean test score was 79. So my mean and my median are really close here, 79 and 79.5. I like it when that happens. We'll talk about what that means in just a second. Okay, see, literally just a second. So here you can see what the shape of a distribution is based on what the median and the median are, mean and the median, are when they are compared with each other. So if you take a look at this, and if the mean is smaller than the median, then your shape, distribution shape is skewed left. You can see that in that first picture there. If my mean and my median are really close to the same, like with those test scores, there were 79 and 79.5, we have a nice symmetric or bell-shaped curve. Remember, this is a normal distribution. If my mean is larger than my median, or my median smaller than my mean, then we end up skewed right. These are questions you will be asked on a test. So this is something you are going to want to remember. or actually have in your notes really clearly. So remember, the mean is smaller than the median, we're skewed left. They're basically the same, we're symmetric or bell-shaped, we have a normal curve. If the mean is larger than my median, then we are skewed right. Okay, so I'm going to pause right here, and the video is going to look a little weird because I'm going to show you how to find the mean and the median using your calculator.